Classwork 5.3, using logarithms to solve exponential equations. When solving an exponential equation, what should one do if the powers cannot be written with the same basis? You just rewrite in logarithm form if you can't get the same base. Okay. Hey, 10 to the x is equal to 1,000. 10 to the third power is equal to 1,000, so x equals 3. B, solve. 10 to the what power will give you 55? Well, we know it's between 1 and 2 because 10 to the first is 10, and 10 squared is 100, and 55 is between 10 and 100. You can't get the same base, so rewrite it in log form. Log 10 of 55 is equal to x. Put that in our calculator. Log 55 is equal to approximately 1.74. C, 5 to the x equal to 145. I try to write 145 as a base of 5, but I can't, so I'm going to rewrite it in log form. Log base 5 of 145 is equal to x. I want to put that in our calculator, so I have to change that to a base of 10. So I'm going to use my change of base formula. Log base 10. And remember, base goes on bottom, so the 5 goes on bottom. I put that in my calculator. I get approximately 3.09. D, 7 plus 3 to the x is equal to 30. This is, the x is in the exponent, so this is an exponential equation. So I'm going to circle that. I'm going to get that by itself. So to get rid of plus 7, I'm going to subtract 7 on both sides. These cross out. 3 to the x equals 23. Now I try to write this as the same base, but I can't, so I'm going to rewrite it in log. Log base 3 of 23 is equal to x. I just want to put this in our calculator, so I got to change it to a base of 10. And the base goes on bottom. So I put that in my calculator and I get approximately 2.85. E, 7 to the 3x plus 2 is equal to 5. This is an exponential equation because the x is in the exponent. It's already by itself. I can't rewrite it in the same base, so I'm going to rewrite it in log. Log base 7 of 5 is equal to 3x plus 2. I'm going to put this in our calculator, so I'm going to change it to a base of 10. And the base is the 7, which always goes on bottom. I put that in my calculator, I get approximately 0.827 equals 3x plus 2. I subtract 2 on both sides. Bigger number minus smaller number. So you get negative 1.173 approximately. So I'm going to use squiggly lines. Divide by 3, and x is approximately negative 0.39. And that's my answer. So that means if I plug that into the exponent and times it by 3, add 2, and I take it 7 to that power, it's going to be pretty close to 5. Alright, moving on. Inverse property of logarithms and exponents. State the inverse property of logarithms and exponents. So basically, if you have a log of a base and you have a base and you're taking it to the x power, the bases will cancel out and this will equal x. The other one is if you're taking a base and the exponent is a log of the same base of x, this is equal to x. So A, evaluate 10 to the log base 10 of 3. You see how the base is a 10 and the log in the exponent is a base of 10? These will cross out and you'll get 3 as your answer. B, log base 10 of 10 to 3.28. These bases will cancel out, you get 3.28. C, log base 5 of 5 to 3x. Same bases, the log and the base, so they cancel out, you get 3x. D, 5 to the log base 5 of 8 minus log base 4 of 64. Well, these are the same base, so that's 8. Well, log base 4 of 64, that means 4 to the what gives you 64? 3. 8 minus 3 is 5. And that's your answer. This is letter E. Skips. D. So I'm going to go to D. Log base 4 of 64. This means 4 to the what gives you 64, and that's 3. Try. Log base 4 of 4 to the third plus log base 2 of 8. Same base, cancel out, so that's 3. 2 to the what gives you 8? 2 to the third, so 3 plus 3 is 6. That's our answer. Summary. Number 1, log base 4 of 64. This just means 4 to the what gives you 64, and that's 3. 2, log base 4 of 4 to the third. This, I just want to get rid of the log, so I'm going to rewrite an exponential. 4 to the what gives you 4 cubed. That means question mark is equal to 3. And the last one, 3 to the log base 3 of 17. If I rewrite this in log form, this means log base 3 of what will give you log base 3 of 17. So question mark probably has to equal 17. Solving logarithm equations with only one log. How do you solve a logarithm equation with one log? You rewrite an exponential form. A, log base 4 of 3x plus 1 is equal to 2. You see how the log is already by itself? So I'm going to rewrite this in exponential form. So this is going to be 4 squared is equal to 3x plus 1. 4 squared is 16, 3x plus 1. Now this is just an algebra 1 equation, 2 steps. Subtract 1 on both sides. So that's, and divide by 3, so x equals 5. B, log base 4 of 3x plus 1 equal to 2. Now right here, A and B are different because the 3x plus 1 does not have parentheses. So that means I need to get this by itself. So I'm going to subtract 1 on both sides. Log base 4 of 3x is equal to 1. And right here, I'm going to get rid of the log by rewriting an exponential. So 4 to the 1 is equal to 3x. 4 to the 1 is 4. And this is a one-step equation, divide by 3 on both sides. X is equal to 4/3, or 0.7, 1.33. Thank you for your time. This is classwork 5.3. Using logarithms to solve exponential equations. Thank you.